I worked an incident a few years back. Mid-market company. Sales engineer leaves for a competitor. On his way out, he zips up, quote, the project folder, end quote, onto a personal USB and walks. HR is annoyed but moves on. 6 months later, legal calls. The competitor is selling a near identical product, and there is reason to believe the source code, the customer pricing model, and the engineering roadmap walked out the door in that zip file. We pulled DLP logs. The transfer happened. It triggered no alerts. Why? Because nobody had ever classified the data. To DLP, the project folder was just files. Not, quote, confidential, end quote, not, quote, restricted, end quote, just files. The lesson: every data protection control on earth assumes you know what data you have and how sensitive it is. If you skip classification, the rest is theater. Today we fix that. Objective 3.3. Data protection. Let's go. Start with what kind of data you actually have. The exam carves it into 7 categories you should be able to recognize in a scenario. Regulated data, covered by laws like HIPAA, PCI DSS, GDPR. Trade secrets, proprietary business information protected by NDAs and trade secret law. The Coke recipe is the classic example. Intellectual property, patents, copyrights, trademarks. Legal information, attorney-client privilege communications and litigation files. Do not let this leak. Financial information, accounting records, banking data, payroll governed by SOX for public companies, PCI DSS for cards, and GLBA for financial institutions. And then human readable versus non-human readable, which is exactly what it sounds like. Text and structured data you can open in a viewer versus binaries, encrypted blobs, compile code, and compressed archives that need tools. 5 regulations you must know cold. HIPAA, Health Insurance Portability and Accountability Act, protects PHI, protected health information in the United States. Breach notification within 60 days. PCI DSS, Payment Card Industry Data Security Standard, protects cardholder data. CHD. Encryption is required. Tokenization is the most common compliance tool. GDPR, General Data Protection Regulation, protects personal data of EU residents anywhere in the world. Right to erasure, the user can demand deletion. Data minimization, collect only what you need. Breach notification within 72 hours, the tightest of the bunch. GLBA, Gramm-Leach-Bliley Act, financial data held by U.S. financial institutions. Safeguards rule, privacy notices. SOX, Sarbanes-Oxley, financial reporting integrity for U.S. public companies. Access controls, audit trails, segregation of duties. The exam loves to hand you a scenario, quote, a hospital is migrating patient records, end quote, and the answer is HIPAA. Pattern match the data type to the regulation. Data classification. 2 models you need. Government runs 4 levels. Top secret, secret, confidential, unclassified. Top secret is, quote, exceptionally grave damage to national security, end quote. Secret is, quote, serious damage, end quote. Confidential is, quote, damage, end quote. Unclassified has no restriction. Corporate runs 4 levels too, with multiple naming conventions. Restricted or critical is the highest. Encryption keys, board decisions, M&A data. Confidential or sensitive is next. Customer PII, source code, financial forecast. Private or internal is for company use only. Internal policies, org charts, employee data. Public is approved for release, marketing materials, press releases. The exam will use either set of names. Match severity to handling. 2 roles attached to every classified item. The data owner, almost always a business leader, is responsible for classifying the data and setting policy. The data custodian, usually IT or operations, implements the technical controls that enforce that policy. Owners decide. Custodians implement. If you classified it as restricted but never labeled it in metadata, headers or footers, you have not really classified anything. Labels matter because they trigger the controls. 3 states of data. This is the framework that drives every encryption decision you make for the rest of your career. Data at rest, sitting on a disk, a database, a backup tape, a USB drive, a cloud storage bucket. The risks: physical theft, unauthorized database access, stolen backups. The protections: full disk encryption, BitLocker on Windows, File Vault on Mac OS, dmcrypt or LuKS on Linux. Database level encryption, transparent data encryption, TDE in SQL Server, Oracle, MySQL. File and folder encryption like EFS or PGP for specific items. The standard symmetric algorithm is AES-256, and this is the one that gets people fired. Backup encryption. A stolen unencrypted backup tape is a reportable data breach in every regulated jurisdiction. Data in transit, moving across a network between application components over a LAN or WAN or the internet. The risks: man-in-the-middle attacks, packet capture, session hijacking. The protections: TLS for TCP-based traffic, which is what powers HTTPS, SMTPS, IMAPS. VPN, IPsec or SSL/TLS, for tunneling everything between endpoints or networks. SFTP SSH file transfer protocol for encrypted file transfer. This is the modern replacement for plain FTP. FTPS is different. It is FTP over TLS, uses different ports. Do not confuse it with SFTP. The exam will absolutely try. Data in use, actively being processed in memory. Risks that did not exist 20 years ago, but absolutely do now. Memory scraping by malware. Cold boot attacks where RAM is physically extracted while still warm. Insecure process memory dumps from a debugger. Protections: secure enclaves, Intel SGX, AMD SEV, hardware isolated memory regions for sensitive computations. Memory encryption, so even physical extraction does not yield plaintext. Application level discipline: keep sensitive data in memory only as long as needed, then zero it out. Of the three states, in use is the youngest field and the hardest one to defend. Data sovereignty: where data physically lives determines which laws apply to it. EU personal data sitting on a server in Virginia is still subject to GDPR. The company has to either ensure the US server meets GDPR standards or use standard contractual clauses, SCCs, to bridge the gap. Data stored in China is subject to China's cybersecurity law, which gives the government a path to demand access. Cloud providers expose this through region selection. AWS regions are isolated by default. Your data does not leave a region unless you configure replication. Azure has geo-replication pairs and explicit data residency commitments. PCI DSS, HIPAA, and GDPR all have residency implications. Pick your region with the regulation in mind, not just with the latency in mind. Now the methods. Rank them. Encryption is the most important data protection control on Earth. Transforms plaintext into ciphertext using an algorithm and a key. Protects confidentiality even if every other control fails. The catch is that encryption without key management is theater. Keys must be stored securely. HSM is the gold standard, rotated regularly and access controlled. Encryption at rest plus encryption in transit is the minimum bar for any sensitive workload. Hashing, not encryption. Do not let the exam trick you. A one-way transformation producing a fixed length digest from input. You cannot reverse it. You use it for integrity verification, not confidentiality. If two inputs produce the same hash, that is a collision, and collisions are how MD5 and SHA-1 died. Current standards are SHA-256 and SHA-3. For passwords, never use a fast general-purpose hash. Use a salted, slow, password-specific function. Bcrypt, Argon2, PBKDF2. The slowness is a feature. It makes brute force expensive. Masking. Hides part of sensitive data while preserving format. The real value still exists somewhere. Only the displayed version is obscured. Showing, quote, *****, 1, 2, 3, 4, end quote, for a credit card on a receipt is masking. Used in customer service screens, log files, reports, anywhere the full value is not needed by the viewer. Masking is not the same as tokenization, and the exam will absolutely test this confusion. Tokenization replaces the sensitive value with a non-sensitive surrogate, a token, that has no mathematical relationship to the original. A token vault holds the mapping. If you need the real value back, you ask the vault. The token by itself is useless. This is the primary mechanism for reducing PCI scope. Systems that only ever see tokens are out of scope for PCI DSS. Only the payment processor holds the vault. Compare the three you must distinguish. Masking shows a partial real value, no reversal needed because nothing was replaced. Tokenization replaces with a surrogate, reversible only via the vault. Encryption replaces with ciphertext, reversible via the key. For PCI, tokenization is the storage answer. Encryption is the at-rest and in-transit answer. Masking is the display answer. Obfuscation. Less rigorous than encryption, makes data harder to understand without fully encrypting or removing it. Obfuscated JavaScript on a website. Pseudonyms instead of real names in a test dataset. Useful as a deterrent against casual exposure. Not a substitute for encryption against a motivated attacker. If your defense for sensitive data is, quote, the variable names are weird, end quote, you do not have a defense. Segmentation. Isolate sensitive data to specific systems and network zones. The classic example is the PCI cardholder data environment, the CDE. Cardholder data lives in its own segment with strict ingress and egress rules and nothing else. Reduces blast radius. An attacker on the corporate network does not directly reach the CDE. There is another firewall, another set of controls, another audit trail in the way. Network segmentation plus data segmentation is defense in depth. Permission restrictions and access control. Need to know. The user gets only the data their job requires. RBAC, role-based access control. Permissions assigned to roles, users inherit from roles. ABAC, attribute-based access control. Decisions based on user attributes, data attributes, environmental attributes like time of day or location. Least privilege, minimum required, reviewed regularly, revoked when not needed. And DLP, data loss prevention, monitors and controls data movement, blocks unauthorized transfers, alerts on policy violations. DLP is what should have caught the USB exfil in the cold open if only somebody had labeled the project folder as restricted. Data lifecycle. 6 phases, each with its own security concern. Creation and collection. Classify at creation. Collect only what you need. Data minimization. Storage. Encrypt at rest. Access controls. Backups. Use. Access logging. DLP. Secure memory handling. Sharing and transmission. Encrypt in transit. Authorized recipients only. Archival. Encrypted archives, retention policy compliance, and disposal, secure deletion, DOD 5220.22, wiping for magnetic media, degaussing for tapes and old hard drives, physical destruction for solid-state drives where overwrite is unreliable. End of life is where lazy organizations create breaches. A donated server with an unwiped drive is a story you read in a state attorney general report. Scenarios to lock the methods in. Scenario 1, quote, the dev team needs realistic test data without exposing real customer PII, end quote. The answer is not encryption. The test environment needs to read the data. The answer is masking, or pseudonymization, or synthetic data generation. Show the format, hide the values. Scenario 2, quote, the company processes credit cards and wants to reduce PCI scope, end quote. The answer is tokenization. Card numbers get replaced with surrogate tokens. The systems handling the tokens fall outside the scope of PCI DSS. Scenario 3, quote, a US hospital sends imaging files to a cloud diagnostic service, end quote. The answer touches HIPAA. The data is PHI. And requires encryption in transit, encryption at rest at the cloud destination, a BAA signed with the cloud provider, and access controls limiting who can pull the records. Pattern match the data, the regulation, and the control. One area people under test, secure deletion, standard DoD 5220.22-M. Overwrite worked when storage was magnetic. Solid-state drives use wear leveling, which means an overwrite of a logical block does not necessarily overwrite the physical cells holding the original data. For SSDs, the right answer is hardware-supported secure erase, ATA, secure erase, or NVMe, secure erase, or physical destruction. For tapes, degaussing destroys the magnetic field and renders the tape unrecoverable. Match the method to the medium. Cloud disposal is its own discipline. The provider does not let you physically destroy their drives, so cryptographic shredding is the answer. Encrypt the data with a key, then destroy the key. The data remains physically present but is mathematically unrecoverable. This is how every major cloud provider implements customer-driven deletion, and it is the textbook answer for cloud data destruction. Action checklist. 1. Classify your data before you protect it. Owners classify, custodians implement, labels are mandatory. 2. Match the data type to the regulation. PHI goes to HIPAA. Card data goes to PCI DSS. EU personal data goes to GDPR. Financial reporting goes to SOX. Financial institution customer data goes to GLBA. 3. For at rest, AES 256. Full disk encryption, TDE for databases, and encrypt every backup tape that ever leaves the room. 4. For in transit, TLS, VPN, SFTP, HTTPS. Never send sensitive data over a clear text protocol. 5. For in use, secure enclaves, memory encryption, and discipline about how long data stays in memory. 6. Hashing is integrity, not confidentiality, and it is one way. Salt your passwords with bcrypt or Argon 2. 7. Masking shows a partial real value. Tokenization replaces with a surrogate stored in a vault. Encryption replaces with ciphertext that needs a key. Pick the right one for the use case. 8. Tokenization is the way to shrink PCI scope. 9. DLP enforces classification at the boundary. If you skip classification, DLP is blind. 10. When data hits end of life, wipe, degauss, or physically destroy. Donated drives are how breaches start. 11. GDPR 72 hours, HIPAA 60 days. Memorize both windows. One last operational note on DLP because the exam will name the modes. DLP deploys in 3 places. Network DLP inspects traffic at the egress choke points, email gateway, web proxy, internet edge, and blocks unauthorized data from leaving over those paths. Endpoint DLP installs an agent on the device and watches local actions. Copy to USB, print, screenshot, upload to a personal cloud account. Cloud DLP uses APIs into SaaS platforms, Microsoft 365, Google Workspace, Salesforce, and inspects data at rest and in motion within the platform itself. Most enterprises need all 3 because data flows through all 3 paths. A network-only DLP is blind to a contractor zipping files onto a USB at a coffee shop. An endpoint-only DLP is blind to a phishing-driven OAuth grant that gives the attacker API access to the SaaS tenant. Defense in depth applies inside the data protection program too. Next up, Objective 3.4, Resilience and Recovery in Security Architecture. We have talked about where data lives and how we protect it. Next, we talk about what happens when the disk fails, the data center burns, the ransomware lands, or the region goes dark. Site types, backup strategies, the 4 metrics, RTO, RPO, MTTR, MTBF, and the 3-2-1 rule that the exam treats like scripture. See you in 3.4.